So today's lesson is area between two curves with respect to y. In last lesson, we talked about area between two curves in respect to x. For example, the area is formed by stacking vertical rectangular shape along the x-axis, and we call that a definite integral from a to b of f of x dx. In today's lesson, we're going to examine the area between two curves in respect to y, where rectangular shape is formed horizontally, which means the integral of c to d of g of y dy. Now let's look at example 1 to examine why we need to learn how to solve area between two curves in respect to y. Okay, so example 1. Find the area of the region bounded by the graph of f of x is equal to 2, g of x is equal to 2x plus 2, and h of x equal to negative 2x plus 6. Here's the graph. Now the area that we want to calculate is that pink region. Okay, so let's try to solve this pink area in respect to x first. Notice the top function changes in between. G of x is a top function until they intersect, and then the h of x becomes a top function afterward. So which means if you want to solve this area, we have to look at it as two different integrals or two different areas. So if you were to write it as an integral, we have to find this blue region first and add it with this green region. This area of the blue will have a top function of g of x, and the area of this green will have a top function of h of x. So if you want to write an integral, we have to find the way they intersect first. To find the intersection, we have to use system equation. So h of x is equal to negative 2x plus 6. This has to equal to our g of x, which is 2x plus 2. 2x plus 2. If you solve an equation, you'll find that they intersect at x equal to 1. Now we found out that h of x and g of x intersect at x equal to 1. With similar concept, we'll find that h of x and f of x, they will also intersect at x equal to 2. Now let's find the blue area first. Blue area is equal to integral of 0 to 1. Top function is 2x plus 2 minus the bottom function is f of x, so it's 2 dx equal to integral of 0 to 1 of 2x dx. Integral of 2x is equal to x to the second power, and solving this from 1 to 0, which is equal to 1 minus 0. So the blue area has an area of 1. Now for the green area, your top function is h of x, and you're integrating this from 1 to 2. Top function was negative 2x plus 6. And the bottom function was 2 dx. Integral of 1 to 2 of negative 2x plus 4. Integral of negative 2x is negative x squared, and integral of positive 4 is 4x. Solving this from 2 to 1. And if you solve this definite integral out, you're going to get a 4 minus 3, resulting in area of 1. Since the blue area was equal to 1 and the green area was also equal to 1, the total area is equal to 2. Now to find the area of pink region, we needed to use 2 integral to solve it out because the top wasn't consistent throughout the entire area. Now if you were to solve this area in respect to y, you will only need one integral compared to 2. When you're solving in respect to x, you are forming the rectangular shape vertically. Therefore, you are looking at top function compared to the bottom function. Now, when you're solving in respect to y, you're forming the rectangular shape horizontally. So you'll be looking at a consistent right function compared to consistent left function. Now, let's look at this case once again. Your right function will be h of x. Your left function will be g of x. Now, because you want to solve it in respect to y, these function needs to be solved as x equal to. Our g of x, which is y equal to 2x plus 2, is same thing as x equal to y over 2 minus 1. Now our h of x was y equal to negative 2x plus 6, and this will equal to x equal to negative y over 2 plus 3. Earlier we found that h of x and g of x intersect at x equal to 1, comma 4. So now our integral will be from 2 to 4. Because we're solving in respect to y, we're looking at the y coordinates. It starts at 2, ends at 4. Area is equal to integral of 2 to 4. And our right function was negative y over 2 plus 3. And our left function was y over 2 minus 1 dy. Now if you simplify the integral, this will equal to integral of 2 to 4 negative y plus 4 dy. Integral of negative y plus 4 is equal to negative y squared over 2 plus 4y from 4 to 2. Now if you substitute 4 into negative y squared over 2 plus 4y, you will get positive 8. And if you substitute 2 in, you will get 6. So the answer will be 2. So the area is equal to positive 2. So as you can see, both methods will get you the answer of 2. If you solve it in respect to dx, you'll have to separate the area into two pieces because they have different top. But if you solve it in respect to y, you could solve it as one integral because there's consistent right function. So depending on what kind of function you have, you might want to consider using in respect to y or in respect to x to solve the area between two curves. Now moving on to next example. Find the area of the region bounded by the graph of f of y equal to 7 minus y squared and g of y equal to 2y plus 4. So now they gave us the function in terms of y already. And they want to find the areas that's bounded by the linear function and this quadratic function. So the area we're solving is this pink area. Looking at the sketch, we don't have a consistent top. Your top changes from the linear, and at this intersection it changed to quadratic. So this might be easier if you solve it as in respect to y. Your consistent right function is your quadratic, and your left function is linear. In order to write the integral, we have to figure out this intersection point and this intersection point, because that's where the area starts and where it ends in terms of y coordinates. And you could solve this out once again using system equation. You'll find that they'll intersect at negative 3 and y equal to 1. So our area will be integral of negative 3 to 1. Your right function being 7 minus y squared. Subtract by your left function 2y plus 4 dy. Now if you simplify this, this will equal to integral of negative 3 to 1 negative y squared minus 2y plus 3 dy. Now integral of negative y squared minus 2y plus 3 is equal to negative y to the third over 3 minus y squared plus 3y from 1 to negative 3. Now if you evaluate this equation at 1, you will get 5 over 3 minus, and if you substitute negative 3, you will get negative 9, and 5 over 3 minus negative 9 is 32 over 3 as your final answer. So the area that is bounded by those two graphs is equal to 32 over 3. So to summarize the area between two curves, if your function is given a consistent top, it's easier to solve it as respect to x. And if your function is given consistent right function, it's easier to solve it as in respect to y. Now in respect to x, don't forget your interval has to be in terms of x. It's top function minus bottom function. If it's respect to y, your interval becomes your y coordinates and it's right function minus left function.